The number 1001 is the product of the prime numbers 7, 11, and 13. Knowing this, what is the prime factorization of 40,040? We've got some options. Let's go. So the given information in this problem is a little bit funny, but the basic idea of prime factorization is something that you definitely need to know, and I hope that kind of rings a bell when you hear it, prime factorization. Now, you may not remember the details, which is why we're here. Let's do it. They want us to do a prime factorization of 40,040, but that's a big number, and I want to explain it with a simpler number first. And to do that, let's talk again about what's a prime number in the first place. A prime number is a number that can only be divided by 1 and itself. So the number 2 is prime because it can only be divided by 1 and 2, 1 and itself. Or the number 3 is prime because it can only be divided by 1 and 3, or 1 and itself. 4, though, is not prime because 4 can be divided by 1 and itself, 1 and 4, but it can also be divided by 2, so it's not prime. Right? A prime number can only be divided by 1 in itself. And when I do a prime factorization, it goes something like this. Let's do a smaller number like 24. And if I want to do a prime factorization of 24, what I do is I say, well, hey, 24 could be broken into, I don't know, for example, 3 times 8, right? 3 times 8 would give me 24. So I could break 24 into 3 and 8. 3 I can't break down any further because that's a prime number. It only divides by 1 and 3. We're done with that part of the branch. What about 8? 8 I can break up further. 8 could be divided into 2 and 4, for example. Okay, well then if I go there, I guess the 2 is done because that's prime and I can't go any further than that. But the 4 I could still break in to 2 times 2. And now I can't go any further because 2 is a prime number. I can't break this down anymore. But what I've learned is that, well, 24, if I broke it into prime numbers, this could be written as 2 times 2 times 2, so 2 cubed times a 3. And I've got 2 cubed times 3 is equivalent to 24, and this is the prime factorization of 24. This is the process. Now, 40,040 is a way bigger number, but it's the same process, and I want to walk you through it, and I want to explain why they gave you this weird little piece of information too. So we've got the number 40,040, and I want to break this down a little bit at a time. What I'm going to do is I'm going to say, I know that anything that ends in 0 is always going to be divisible by 10. So I'm going to say this is 10 times something. And I'm going to do my calculator to figure out what that is. I'm going to say 40,040 divided by 10. And when I do that, I realize that this is 4,004. So I could break 40,040 into 10 times 4,004, for example. Now 10 I can break down a little bit further. That could be a 2 and a 5, right? 10 is 2 times 5. Those are both prime, so I can't go any further over here. But 4,004 I can certainly break down further. I notice that it's divisible by 2, for example. So this is 2 times something. And if I use my calculator for this and do 4,004 divided by 2, I get 2,002. All right, well, I could still go further here. The 2 is otherwise, though, done. Well, 2002 could be divided into 2 and 1,001. You can use your calculator for that if you need to. Well, look at that. I know that 2 and 5 and 2 and 2 are prime numbers that are factors of this. Meanwhile, I've still got to break down this 1001, which is why they gave us this funny little piece of information here. They told us that 1001 is the product of 7, 11, and 13. So if I did the factorization of this, I'd get 7 times 11 times 13. We can take their word for it. But now if I take inventory of everything I have here, this is the prime factorization of 40,040. So I've got 2 times 2 times 2, which is 2 cubed. And then I've got a 5, that's the only 5 I have, so times 5. And then I've got a 7, that's the only 7 I have, so times a 7. And then I have an 11 and a 13, so I've got an 11, and I'll squeeze this in here in a 13. And then this would be the prime factorization of 40,040. And if I look carefully at my answers, that means my answer is E. Now, if you picked B, for example, this is correct in terms of its value does give me back the 40,040. But notice 40 is not prime, so this was not the prime factorization that they were looking for. But if you did get E, great thinking.